OpenShift installation automation with iserver application. iserver is open source command line application that based on user input can install OpenShift on bare metal servers, as well as check or configure data center network for servers connectivity. Check an overview video in the playlist for more information. The focus of this video update is the OpenShift bare metal cluster installation that runs based on user input. Refer to GitHub for complete explanation of the input data model. Cluster.json defines base cluster parameters, including OpenShift version, cluster and network services CIDRs, CNI type or API ingress IP addresses. SSH access based on public key is enabled from a single SSH public key defined in ssh.pub file. More SSH keys can be defined in post-installation or day-to-ops tasks. If your environment is connected to internet via HTTP proxy, define the proxy settings in proxy.json file. Web server is where generated ISO will be uploaded to, and later on vMedia mounted by the servers to boot from. Web server can run on the same host on which iserver application runs on. This is the example on this slide. But it can also be remotely accessible via SSH, and please check GitHub for examples for WebJSON content in such case. iserver also needs Redfish access to servers. The Redfish credentials can be defined per server in server.json file that you will see in the next slide. It can also be defined globally in the dedicated redfish.json file. Bare metal servers where OpenShift cluster will be installed are defined in server.json file. Define two IP addresses there for every server, one for Redfish, that is on management interface of the server, and another one is for SSH, that will be defined on the interfaces selected by MAC address. Only the interfaces for Kubernetes cluster are defined here. Other interfaces used for storage or extra networking should not be defined at this stage. In this example, two physical interfaces are defined by MAC address. They will form ether-channel bond as defined in the nmstate format. iserver supports the templates for nmstate files that can be reused across different cluster definitions. As such, bonding YAML file that you see on the right has variables that are defined in the server.json file. If the cluster node has single interface for main Kubernetes access, then as a reference, this is the nmstate file example with variables defined in server.json file. iserver leverages the OpenShift console capabilities of third-party CNI configuration controlled via REST API. To my knowledge, it is not exposed to assisted installer UI. On iserver level, all you need to do is defining network type other than OVN Kubernetes, for example, Cilium. As well as you need to add all custom manifest files to input directory in manifest subfolder or subdirectory. CNI manifest can be further defined with custom variables, and the variable values are defined in server.json file. When you have all the data defined, you can initiate an OpenShift installation workflow. Workflow interacts with OpenShift console, server, and web server as indicated with colors. Once verification is complete, cluster is created, manifest uploaded, ISO generated by OpenShift assisted installer, and then is downloaded and uploaded to the web server. All servers are configured to boot from this ISO. Once the servers are rebooted, they should eventually call home to console SaaS and be discovered by Red Hat assisted installer. Then hosts are configured, meaning the name, NTP settings, as well as cluster role. And then installation is started and should run to completion. Once installation finishes, kubeconfig file is downloaded from OpenShift Cloud and uploaded to selected server in the cluster so that OC or kubectl commands can be used right away. And that ends the entire workflow. This is the color-coded output of iserver application showing the workflow in action. What you will get if you decide to use iserver application? You can define OpenShift cluster once in the set of files, and later you can use it to install or reinstall the cluster, getting exactly the same outcome. Extensive checks eliminate fat finger errors or exit early to avoid long waiting to figure out that something went wrong. Workflow is fully automated and does not require user actions. Check GitHub for documentation, input data model, more examples as well as sources and binaries.